Okay, good morning. Are you ready? So let us start this lesson. The first chapter, as I told you, the first chapter in the book is eliminated, has been moved to Math 5. So we start in chapter 2 in the book, which is the first chapter that we want to study in Math 4. Okay, and that is about trigonometry. You probably should know at least a little bit about trigonometry from Math 2C course, and then probably last year in Math 3C course, the last chapter. But I will not take any of those for granted, okay? So I completely start from scratch as if you don't know anything in trigonometry, okay? But this is a very long chapter, and that's very important. So try to practice as much as you can. I will try to provide you with extra problems. And if you're ambitious, you want to have a better grade, guaranteed it's better to work some of them out. And if you don't know, you can come and ask. Okay, so I want to talk about trigonometry in the unit circle. What I want to do today is just define what I mean by the unit circle. So this is a terminology. I want to define it for you. So there's a big concept there. So probably you somehow can guess what is the meaning of the unit circle. Circle is a geometrical shape. All of you know about it. And unit means of unit length. What is of unit length here is the radius. So when I say the unit circle, I am referring to a particular circle, the circle in the coordinate system. That's also important, okay? Because in principle, you can draw a circle with radius 1 somewhere without having the coordinate system. But when I talk about the unit circle, I mean the unit circle whose center is at the coordinate system, yes? And the length of the radius is one length unit, whatever that unit is, yes? So I draw that. Okay, so this is the unit circle. Before going a little bit further, so if I ask you what is here, what are the coordinates of this point? What are they? Yes? 1 and 0, because I just told you that the center is here, the radius is 1, so this is one length unit, and because it is on the x-axis, the y-coordinate should be 0, so you know that the coordinate here is 1 and 0. Similarly, the coordinate here is 0 and 1 here. Let's just say it. Negative 1 and 0, and then here 0 and negative. So that's very simple, okay? But before going any further, I want to see something about this. So let me pick a random point on this unit circle. Wherever you want to, it doesn't matter, okay? So for example, let me choose this point here, and I call it point P. So you know that this point P lies in the coordinate system, so it should have a x coordinate and a y coordinate, yeah? So I will call it x and y. So if I say what is P, you will tell me that P is just a random point on the unit circle as I describe it right now for you. And what are X and Y? X is the X coordinate of that point in this coordinate system, and Y is the Y coordinate. I want to discover what is the relation between X and Y. Can I say something for X and Y here? Are X and Y, for example, can X be 3, Y be 2? Or what is the rule behind that? So can you tell me, wherever P lies, is there any particular connection between X and Y coordinates of that random point that I choose on the unit circle? Yes?
X squared plus y squared is 1.
Yeah, is that right? Because do you remember there is a distance formula that you had in Math 2C? So let me remind you of that as well. So if we have a coordinate system, and if I have 2 points, let us say one point is here, the coordinates are x1 and y1, and another point here, the coordinates are x2 and y2, I can ask you to determine the exact distance between these 2 points. And then let me call that one D. Yes? I don't know how many of you remember, that's called distance formula that you had in Math 2C. So what is, if you have forgotten, by the way, try to work on your memory, okay? It's very, very important because I know that you have used to ignore memory. It's a very bad habit, I would say. So let us at least try to remember. So what is D? the formula for telling me the distance between these 2 points if I give you the coordinates of that point and the coordinates of that point. So do you remember something? So that is bad, okay? Of course, I understand the philosophy behind Swedish education system. They want you to discover everything every time. It's good on one side, but it's bad on the other side. This is the example I use. Whenever I come here, yes, I have some keys in my keyring. Okay, in principle, I can solve the problem every time that I appear in the morning, yes? Because, for example, there are some keys. If I don't have it in my memory, which key opens this door, and then I will try to do some trial and error, or try to figure out what is the shape of the keyhole, which one fits this one, and try to solve the problem. But I hope that you agree with me. If I want to repeat it every time and you are standing there for me, yeah, you will become unhappy. So try to use your memory, okay? It's important. Yes? Yes. Well, that was the formula, okay? So, I mean, of course, in principle, you can find a formula every time from scratch, but it is not a good idea. Because if the problem is simple, yes, you can but if I have a complicated problem that we will have in this course, then if you want to remember and solve every bit of that problem from scratch, either you will lose time or you become crazy, okay? So you have to actually solve the problem. You need to manage. By the way, when you go to, for example, KTH, that's a bad thing. They will not allow you to have a formula sheet at all, and the formula is 10 times more than the formulas that you need here. And of course, in the basic courses, the calculator is not also allowed. So try not to be so dependent on it, okay? Even sooner or later, you have to give up this habit. Okay. So don't underestimate the role of the memory. Okay, but if you have underestimated that, then you have to be able to solve it from scratch, yes? So for example, you draw these two parallel lines, parallel with the x and y axes, and then you would say, for example, what is this distance? No, this one is the difference between x's. Yes, so this is the difference between x's, but in this picture, x2 is on the right, x1 is on the left. So if I want to keep this length positive, as length means positive, so I have to write x2 minus x1. Okay, and then what is this distance? Yeah, y2 minus y1. And then you know the Pythagoras theorem. So d squared is equal to this length squared plus this length squared, yes? And I am looking for d, so I take square root. Yes? When I take square root, is it right? Are you happy with this? Yeah or not? Yes or no? Why not?
You just simplify.
Okay, so okay, I will come back to it, okay? But is something disturbing you or not? Are you happy? You can sleep well? Yes?
You don't know the values.
No, the values is this. I'm solving this by variables. I'm saying that whatever x1, x2, and y1, y2 is, okay, we want to have this formula. But you shouldn't be very happy here. Samir, do you want to sit here if you cannot see? Yeah. So let's just wait a little bit. If you are not comfortable with having you in the video, let me. Okay, coming back now. So you shouldn't be that happy here. Why? Because, for example, if I give you x squared equals to 4 and I ask you find x, what do you say? What? Yes? Okay, so now I understand why you are happy here. Because you're also happy here. Yes? But who is disturbed? Yes? Yeah, plus or minus. Yes, we should put plus or minus. Plus or minus the square root of 4, because what is this asking you? This is asking you give me all possible numbers x so that x squared is 4. How many numbers are there? How many numbers are there? 2. One of them is positive 2, because positive 2 to power 2 is 4, and also negative 2, because negative 2 to power 2 is also 4. Yes? So whenever you have an even number here and you want to take the root, you have to remember you have to put plus and minus 4. Okay, one question I will come back to. So which one is correct? Yes?
Plus or minus 2.
Okay. Anyone? Any ideas? There are three of them on the board. Which one is correct? Yes?
Well, the positive one because it's distance. So
No, we don't have anything to distance. Go back to Math 1C. This is Math 1C now. Forget about distance. I'm just asking you, I write the square root of 4 plus or minus 2. I write square root of 4 is 2. I write square root of 4 is minus 2. Which one of these three is correct? Yes? The first one. Your opinion? Yes?
All of them would be correct.
All of them? Yes?
the second one.
The second one? Okay, so okay, so yes?
If only one, then the first one, but all of them would work.
Okay. Yes, the people who are saying all of them is working, somehow they understand the problem, but they don't know the convention. Okay, so only the second one is true. Okay? Because there is a convention going on. When I say x to the power of 2 is 4, and I ask you, give me all possible values that fits into this equation, then you have to tell me plus 2 and minus 2. Because plus 2 works, 2 to the power of 2 is 4, minus 2 also works. Minus 2 to the power of 2 is again minus 2 times minus 2, which is positive 4. Is that right? So be careful. This is a little bit different story than this one. Okay? But here I am calculating a number. For example, if I say 1 over 2, you can say 1 over 2 is equal to 0.5. Here I am asking you, what is the square root of 4? So a square root of 4 is not asking you, give me all numbers whose second powers are 4. Yes? In that case, you are right. All of them are true. But there is a convention here that this symbol, when you see it, it means give me the positive one. Yes? So there is nothing to understand here. There is a convention that this symbol refers to only one of them. Okay? Is that clear? So for example, let us try to learn GeoGebra right away. So for example, if I want to go to GeoGebra, if you can use your calculator, by the way. So I have this virtual keyboard, so I press it, and then I press 4 on it. Answer is 2. It doesn't matter how many times I type this, I will always get 2. So a square root of 4, by convention, is the positive one. Yes? Is that clear? Okay, so remember, if I have an equation, and I want with even power here, and I want to find the values of x that fits in this equation, I have to put plus or minus. You see that plus minus is coming before square root of 4. Okay? A square root of 4 is still 2. The reason the answer is plus or minus 2, because plus or minus 2 is coming before even that symbol. Is that clear? Yes or no? So the bottom line is that when I ask you what is the square root of 36, what is the answer?
6.
It's 6. If I want to write minus 6 using this symbol, what should I write?
Minus square root.
Minus the square root of 6. Okay? This is the only way that I can write minus 6. So this is something. Okay, now, are you disturbed now or not? So because do you remember what was the original version? The original version was this. And I told you to do what? Give me a number, d, whose second power is this number. So what is d? Yes?
Plus minus.
Plus minus, yes? I want you to understand that. Of course, you know that the minus sign is wrong, not because of the algebra. You have to do the algebra right. But why here in this context, I know something more about d. What is d? d is the length cannot be negative. So as far as you are looking for a number d with that property, you have two of them. Yes? But in this case, the second one does not make sense. It means that I am telling you the length between these 2 points is -5, which is nonsense. Okay, so that is the reason. In principle, if you want to be very rigorous, you have to write this and then write an English sentence here, because d refers to the length cannot be negative, so the negative answer is not acceptable. I only end up with the positive. Okay, is that clear? Okay. Sometimes I tell these things because I have experience. People don't know these things very well. So now, from now on, 100% confident that the square root of 4 is just this one, not that one. And if someone asks you why, because there are two numbers whose squares are 4, why you choose the positive one, what do you say? It's a convention. It's a convention between mathematicians. Let us use this symbol for the positive one. They could have chosen this symbol for the negative one. Yes? Okay. Anyway. Let us go back to the same question. Okay, so what was the question? The question is that I have the unit circle centered at the center at the origin, and then you have the radius 1, and then I am telling you pick a random point on this circle wherever you want to. I want to discover what is the relation between x and y. Actually, Samir mentioned that this relation is x squared plus y squared is equal to 1. I want you to send this to your memory. Okay, I have to remember to switch back and forth. Okay. Anyway, why this is true? So it doesn't matter where do you pick this point. If I pick this point here, this will be the x coordinate, this will be the y coordinate. But if I pick the point here, the x coordinate is smaller and negative, and the y coordinate is bigger and bigger. But I am claiming that it doesn't matter if you choose this point and choose x and y these values, or you choose this point, choose x and y these values, both of them will satisfy the same equation. Okay? Is that clear? You want to prove this. Why is that true? Yes?
Because the length becomes the hypotenuse of a right triangle.
Uh-huh.
Where
Uh-huh.
y are lengths.
Yeah. Yeah, that's correct. But instead of that, I want to use the distance formula, if you don't mind. Let me calculate the distance from this point to the origin. I already know this distance. What is that distance? It is the yes, 1. It is the unit circle. So the distance is the radius of the circle. It doesn't matter where P is. Wherever P is, the distance becomes a radius, and the radius is 1. Okay? And now, according to distance, so this is my distance now between the origin O and P. And I know already d is 1 on the one hand. On the other hand, I know this formula for the distance. So how can I do that? D is the square root of the difference between x coordinates, which is x minus 0, because the x coordinate of the origin is 0 squared, plus the difference between y coordinates squared. Yes? So on the one hand, I know d is 1, so instead of d, I can put 1. And on the other hand, I can simplify this algebraically a little bit. And this is the case. And of course, I raise it to power 2, yes? I want you to know that. So whenever you have a point on the unit circle, the coordinates of that point satisfies this very simple equation, x squared plus y squared is equal to 1. Okay, I remember you said something, and that is a common mistake. You said that we simplify this formula. Can I simplify that formula? I know what is in your head, okay? And I want to try to correct that one, yes? So how can I simplify that? Can I simplify that? By the way, if you have this formula in the formula sheet and not the simplified version as you think, it means there is no simplified version for it. Because mathematicians die for simplifying things. And if you write it something like that, it means that it was not possible probably to simplify that, or the person who wrote it was a stupid mathematician, yes? So if you ignore that part, probably there is something wrong. How can I simplify that? Can I do really simplify this? Because, yeah, you understand your mistake, yes? Because people sometimes think and confuse two different relations. If I tell you square root of a squared plus b squared, if you think that you can write this, that is completely wrong. And I don't think it hurts if you write it and cross it over. Okay, so square root of a squared plus b squared is not equal to a plus b. Okay, why is that, by the way? Because most of you have Math 5. This is the topic of Math 5. If I say, why do you believe this is not right, what do you say? I just want you to understand. You cannot force me, Babak. No, this is wrong. Why? No, I know this is wrong. This doesn't work in mathematics, yes? So if I want to say why this is wrong, what can you say? Because I hope that you understand chapter 1 of Math 5 before I teach you. Because mathematical proof is based on the logic and everyone is actually having that. Yes, here this time.
Because a squared plus b squared is a plus b multiplied by a minus b.
No. A plus b multiplied by a minus b. Everyone, what's the answer? Yes, everyone. Here is, you don't think that here is math 2c, is it? It's math 4. So a plus b times a minus b, what's that? Work on your memory. Yes? Try to start working on it. Yes? What's the answer? What is the name? Yes?
Conjugate.
Conjugate. So this one is a squared minus b squared. Yes? Okay, so a squared plus b squared cannot be written in that way. Okay, why this formula is not correct? Don't take it because I am telling you. Yes?
If you do like proof of contradiction, because,
Say something.
because you show that a plus b squared is equal to a squared plus 2ab plus b squared
Yes?
instead of a squared plus b squared.
Okay, so that is not working. We will talk a little bit about that in Math 5. Because you are saying that a squared plus b squared is equal to that what you mentioned, so it cannot be equal to this one as well. Because you say that a plus b squared is a squared plus b squared plus 2ab, and this is not that one. But this is not working. Because someone can come up and say that, okay, how do you know that these expressions are not equal? But you cannot say, okay, agree with me, they are not equal because they look not the same. But 2 over 4, if you ask a kid, okay, is 2 over 4 and 0.4 look like the same? They don't look like the same thing, but they are equal. So because the form, mathematical forms are different, we cannot say that, okay, because they look different, they are different. Exactly, yes? And that's exactly what we want to learn in the future. So a plus b squared and a squared plus 2ab plus b squared, are they identical? No, they are equal. Okay, so if a person does not know algebra, this thing and this thing for that person are not the same things. Yes? But in mathematics, we learn that if a and b are referring to numbers, whatever the output of this is, that is also the same. So we have to prove it, even though they don't look like the same thing. Do you understand me? And we will talk about that a little bit in math 5. But can you tell me why this is not correct? So your logic is not working. Yes?
If you square both sides, you will get a squared.
No, that will be the same thing as Abdul Rahman, yes? What was your name? Yeah. That's more or less the same thing. But if you want to say that this is not true, what does it mean? How do you do that? So you want to disprove this, you want to refute this. There's one very simple way, bringing an example that doesn't work. Okay? And that is called a counter example. So if you want to prove something, it doesn't matter if you bring billions of examples that works, you have to have an argument for it. But if you want to refute something, you just can invent one example so that it shows it is false. Yes? So if I want to say that this is not always true, I have to bring you an example. For example, I will give you A equals to B3, B equals to B4. Yes? I calculate the left-hand side. What's the answer? Yes? But square root of 25 is 5. The left-hand side for these numbers is 5. What is the right-hand side?
7.
Is 7. So they are not equal. So be careful. If you want to disprove something, if you want to refute something, you can bring an example and show that if you say it works for every number, look, it is not working at least for this pair. So it is not a general rule. But if you want to prove it, you have to prove it. Anyway, so this is not correct. But this one, what about this one? Is that right? It should be with some exceptions. Yeah, so remember, if I have a square root of a squared plus b squared, I am not allowed to take the square root of this one plus the square root of that one. Yes? The same thing for minus sign. But for multiplication and division, we can do that. But of course, we have to be careful because a and b in that case should be positive. If a and b are negative, this still does not work. Of course, here, if both of them are negative, still it works. But if one of them is positive, the other one is negative, it does not work. But so let us be on the safe side and say that a and b are positive. So this is correct. So in principle, you have this one. The square root of a plus b equals to square root of a plus a square root of b, or minus sign. Forget about these two, they are not correct. But if a and b are positive, square root of a times b is equal to square root of a times square root of b. Square root of a over b is also square root of a over square root of b. Yes? So it is, by the way, these are really, really important. They are simple things. If you don't pay attention to these simple things, then you have a complicated problem. Each line of it is a problem for you. Okay? Because you want to think which one is correct, which one is wrong. God, can I do it right now here or not? If you're doubtful about that, you will not be able to solve the problem. Okay? Okay, so let us go back here. This is the formula that we have, so you know that we cannot go further. So we have to get stuck there. Yes? Anyway, now I introduce you the unit circle. That was the lesson we took from here. Now we want to talk about trigonometry. Okay, so the trigonometry that probably you have learned is in the right angle triangle. Okay, I want to change the strategy of teaching that part for you, but let me just remind you. If you have a right angle triangle, yes, A, B, C, and then let me take an acute angle. So we have acute angle. Acute angle means an angle whose measure is between 0 and 90 degrees. So for example, let me say theta. Theta is a Greek letter we use very much in geometry. If this angle is strictly greater than 0 degrees and is strictly less than 90 degrees, that angle is called an acute angle. Okay? Let me give you the word for this one. If it goes to 90 degrees up to 180 degrees, what is the name? You don't know. Obtuse angle. Yes, that's obtuse angle. And if it is exactly 90 degrees, it is a right angle. Yes. Okay, now if I have an acute angle in my right triangle, either this one or that one, because this is not an acute one. And let me call this one theta. And this is common that if you have capital letter for this vertex, the length of this opposite side is denoted by the lowercase letter a. And the same thing here, the vertex is capital B, the length here is denoted by B, and the vertex is here, C is C. Yes? So if I want to define you again, so sine of theta, this semicolon equals to means equals by definition. There is no y in it. I am defining. So sometimes people put semicolons equal. Okay, do you remember something? Sine is equal to what? In a right angle triangle, sine is equal to
A
A over B. It means the opposite side divided by the hypotenuse, yes? So the opposite, yes, divided, let me just abbreviate it by hypotenuse. So in this case, it becomes A over B, yes? And then I have cosine theta. By definition is equal to what? Do you remember? Yes?
The adjacent side.
Adjacent side, okay. But here we have a little bit of problem. If this theta is my angle, which side is adjacent? It seems that both B and C are adjacent. Okay? Yes?
C divided by B.
C. So here, because here we have another name for this one, it is hypotenuse. So when I say adjacent, don't get confused. Technically, both of them are adjacent to theta, yes? But this has a different name, I call it hypotenuse. So when I say adjacent, I mean what? I mean C over, yes? And then do you remember what was tangent? What was tangent? Anyone else? Please contribute. Yes, please. What's your name? M. Yes? Opposite over adjacent. Thank you. Okay, so here in this case, what's the answer? Theta, opposite to theta is A. Adjacent to theta is C. Yes? So this is the tangent of theta. But these are the rules. Of course, I know that most of you does not have these, don't have this in your memory, but try to remember these things. You have to work in your memory, or you will completely lose it, okay? So, this is the way that we define that. Okay, let me test your understanding. Let me call this one, for example, another angle alpha. Okay, can you help me to write sine alpha here? Cosine alpha and tangent alpha, just for practicing a little bit more. So what is sine alpha? Opposite to hypotenuse, yes? So what is opposite here? C, yes? So it is C over B. And what is cosine here? A over B. If you don't understand, please interrupt me, okay? And then finally, what is tangent alpha? C over A. Okay? So this is more or less what you learned before. But what is the weakness of this? If you are a mathematician, you shouldn't rest if you know these things, because some questions should come to your mind. Yes, for example, can you tell me what's the question? Let me go back to GeoGebra, okay? Here, you can see it, yes? Okay, so for example, I type sine. Okay, so as far as I put sine here, so you can see I have sine of x, so I can click on it. Please learn these things. Try to do it yourself to learn, okay? And then I want to, for example, put 125 degrees, 125. And because be careful about that, we will study it more. By default, I think it is in another units, it is not degrees. If you want to make it degrees, you have to go to the function here, you see it? And then there is this symbol there, okay? And then you press it. In that case, I don't know, might be I have already set it up in degrees because it didn't change, you see? And it is extremely important, if you use your calculator for doing it, you have to make sure that your calculator for the time being is set up in degrees mode. There is another mode which we'll go back to it, that's the radians mode, yes? So be careful because the answers are different, okay? Okay, so you see, I typed here sine of 125 degrees and I got an answer. Do you think that this application is calculating it wrong? Probably not. But it does not make sense here, does it? Why it does not make sense here? Why calculation? Can I define you this without telling you further and give this example in the exam and say, okay, that's your problem, calculate it? Is it possible? It is possible if I am crazy, but I'm not that crazy. Yes? So Do you understand that there is something missing here? Why? Why this is not good if I want to calculate sine of 125 degrees? Yeah, because I do not have 125 degrees in a right angle triangle. So even though that is not a big problem if you are working with an acute angle, but immediately it becomes problematic if you want to increase the value of alpha to more than 90 degrees. And even for 90 degrees it does not work, do you agree? Yes? Yeah, I cannot talk about, because this setup only works if that's an acute angle. But if I type here, sine, okay, so let me just type here, sine, and then I just press enter and press enter once more, and then I write 90, and of course, because I have already made the default degrees, it is 1. So sine of 90 degrees is 1. Okay, so this is the reason that we want to expand trigonometry to cover bigger angles. Yes? So this is not a good setup because it will not allow me to do this. Okay, that is why we want to switch to the unit circle. And I want to teach it now here for you. So if I go to the unit circle, but now I want to see the unit circle in the context of trigonometry. In the context of trigonometry, that is the same, but I have two properties added to it. Okay? One property is direction. This is also convention. Counterclockwise is positive by convention. And another thing that I want, another feature I want to add to my unit circle is a point on the unit circle that I want to refer to the origin of the unit circle. Okay? And again, by convention, mathematician has chosen this one on the horizontal axis, not on the vertical axis. Okay? So then let me call this one A, so, and this O. If I ask you what O is, you will tell me O is the origin of my coordinate system. If I ask you what A is, you will tell me that A is the origin of the unit circle. Okay? And then if I ask you what is the positive direction, counterclockwise, so naturally this becomes negative. So what does it mean? It means that if I ask you 30 degrees, okay, if I want to represent it here, always and always, because an angle has two legs, yes? Two arms. The first arm is always on this horizontal axis, always and always. All of them are conventions, okay? And then because I wrote 30 degrees without any signs, I mean positive 30 degrees. So it means that I start from here, rotate about O 30 degrees in the positive direction, and then I stop. Okay? So I start from here, rotate 30 degrees, for example, here, I stop. And this angle is how I represent this angle on the unit circle. Is that clear? I can ask you, show me minus 30 degrees. So then what do? Again, you start from here. Yes? And what do? You rotate again 30 degrees about O, but this time in the opposite direction. So if I start from here and rotate 30 degrees, I will end up here. Yes? So this is the end point. This is extremely important. In this trigonometry, the end point of the angle is more important than the size of the angle itself. Remember that, okay? Is that something you don't understand? Is that clear? Okay, now 125 degrees in this setup does not make sense, but does it make sense here? What do? Again, I start from where? I start from here always and go. Remember this, it's extremely important. Remember, starting R is always here. Okay? And then you rotate 125 degrees in the positive direction. So up to here is how much? 90, so I have to continue a little bit more. So I go, for example, 35 degrees here. Okay, so if I ask you, where is 125 degrees? Remember, from here to here is 125 degrees, yes? But of course, if needed, and if I ask you what do you think about the size of this angle, you can answer that. But that's not that important for me right now. What is the size of this angle? 35 degrees. Yes? Is that clear? Okay. Now, can you tell me another angle that ends up here, but it is not 30 degrees? I just want to see. Anyone else? Yes? What?
390.
200 and 300 and
90.
390. Yeah, that's correct. Do you agree? So you see here, I start from here. 390 degrees is more than 360 degrees. So if I go one full round, how much I cover? 360. I start from here, I go one full round here, I stop here, but it's not finished. I have to go how much more? 30 degrees more. If I go 30 degrees more, I will end up exactly at the same point. So this point, if I want to give an angle that ends here, I can tell you 30 degrees, I can tell you 390 degrees. Are these two angles equal? No, of course this is much bigger than that angle. But the point is that both of them end at the same point on the unit circle. This is important. I want you to understand. I will come why it's important. Okay, can you give me, by the way, this is for your understanding. How many names I can associate with this single point? For example, two names you see. One name is 30 degrees. It will end up here. You told me another number, okay, 390 degrees. How many names I can invent for the angles ending exactly at that point? Yes? What? Unlimited. This is infinitely many. Yes? Why is that? For example, I start from here, go two full rounds, and then 30 degrees more. I will end up exactly there. Do you agree? One 360 degrees, another 360 degrees. So far, how much? 720 degrees. 30 degrees more is how much? 750. So another name for this is also 750. Okay, let me test your understanding. Can you cook up a formula for me that gives all possible names of that angle? This is extremely important, okay? By the way, am I going too fast or too slow? Because you are the first session I am teaching you. Is that understandable for you, what I'm saying? Yes or no?
Yeah.
Okay, if it's understandable, you have to answer me. Yes? Yeah? So, do you understand the question? The question is that, can you write a formula for me that generates all possible names for this angle that ends at this point?
30. 30.
No, let me, yeah? What was your name? What? Melvin, yes.
Be 360 degrees plus 30 degrees.
Plus?
30 degrees. 360 degrees times x plus 30 degrees.
Okay. You're getting close. So you said that 360 degrees multiplied by x plus 30 degrees, yes? Okay? You also have math 5, yes? Okay, so because you have math 5, you have to be precise in writing. If you write this, I will not accept it. Why? Why do you think I will not accept it? It's 99% correct. Yes? Pardon?
X can also be negative.
Okay, but the point is that you didn't say yes. So I cannot hear you. Let me be a better mathematician. It's not acceptable that much. Please remember, it is a myth that in mathematics everything is in symbols and numbers. I can show you. We don't have time. I will later show you that if you see a research article in mathematics, most of it is in English, and the symbols, mathematical symbols, is only 20% or so. Okay? So when you write this, yes?
X needs to be a whole number.
Yes. So you have to tell me, okay, when you write this, the first thing comes to my mind, if I don't know that, of course I know the subject, so I understand what you mean. But let us say that when you want to write things down, you shouldn't count on my own understanding. You have to communicate it with me. So you will tell me that 360 degrees times x plus 30, where you need to write it in English or Swedish or whatever language you have. You have to write where x is a whole number. Because it is clear, if x is not a whole number, this does not work. Do you agree? For example, if I choose x to be 1/2, then what happens? 1/2 times 360 degrees is 180 degrees. And 180 degrees plus 30 degrees is 210 degrees. So 210 degrees is still hasn't reached here, let alone here. Yes? So if I just say 360 degrees x plus 30 degrees, people have right to ask what x is. Okay? So you need to write that this where x is a whole number in English is called is an integer. Yes? Integer means the whole number in English. Yes? We don't say whole number, we say integer. Yes?
So is it wrong if you say whole number?
Grammatically, yes.
But mathematically. Like in the
Yeah, we don't have that one in English literature. Yes? The whole number in English is called integer. Yeah. But I understand what you mean. It doesn't matter that much. But let us learn what you have to write. Okay. And then another thing. Of course, you can choose letter X, but this is more or less common, even though it's not a written rule. People don't use X for integers. They use N. But that is a matter of I don't know. This is a matter of unwritten convention. So if you write that, that is not wrong. Yes? But usually people write where N is an integer. Okay? Do you think n can also be negative integer? By the way, I didn't check that. Do you think n can be -2? Do you agree this will end up exactly there? Why? Because when you say -2, you multiply it here, it becomes -720 degrees. Okay, plus 30 more. Okay, so what do I do? What should I do? So I start from here, I go 2 full rounds, but in the negative direction because that's -2. So 1 full round, I come here. Another full round, I come here, but plus 30, I have to go back again in the positive direction, so I will end up here. So it really doesn't matter. So what you learn is that there are infinitely many names that you can associate with one single angle. Okay? They have different sizes, but all of them end at the very end, the same point. Is that clear? Yes? Yes or no? Okay, but now I cannot continue, so you can keep it up to here, okay? And then we continue probably, I don't know, tomorrow or whatever. Not tomorrow, yes? Next week. Okay, and if you think that I'm going very fast or very slow or whatever, you can just tell me. I don't promise I will adapt myself. Somehow you should adapt it yourself with me, but I will try to take care about that. Questions? Thank you. And always please wait until I click the